Now we will discuss the preparation of ethers. One way to generate ethers is using something called the Williamson ether synthesis. It's basically a nucleophilic substitution reaction. So as an example, if we take an alcohol, we can deprotonate it with a strong base like sodium hydride. So this will get rid of the alcohol functionality and give us the alkoxide. This is then an excellent nucleophile, and we can have an SN2 reaction where we will attack a substrate and kick off the leaving group, generating an ether. Because this is an SN2 reaction, we have to account for steric effects. So if this is our target molecule, there are two ways to synthesize it. The first way is to use this tert-butyl alcohol, this tert-butanol. Alternatively, we could also use methanol with a tert-butyl bromide substrate. So let's take a look at each of these. If we add base to the first example, we will remove the proton here, generate this alkoxide, which is a sterically hindered nucleophile. If we do this in the other example, we remove the proton, generate this alkoxide. This is more hindered, so it will be a slower reaction, but we also have to consider our substrate. So in this case, this is methyl bromide, which is a primary alkyl halide, versus T-butyl bromide, which is a tertiary halide. You should recall that for backside attack to occur, we can't use a tertiary substrate. So because this is a tertiary substrate, it is inappropriate to use for our example. So if we wanted to make this product, we would have to use a more sterically hindered nucleophile, but a less hindered substrate. Another way to generate ethers is using an alkoxymercuration demercuration. You should recall that in an oxymercuration demercuration reaction, we use mercury acetate and water. This generates a three-membered intermediate, and then the water will attack that at the more sterically hindered site, because this site is also more stable in terms of being a carbocation. You can then reduce off the mercury. So this will give us the Markovnikov product. A simple way to make an ether instead of this alcohol is to replace the water here with an alcohol. If we have this same reaction, instead of generating a hydroxyl group over here, the alcohol will act as a nucleophile, and we will have an OR group. And this will also give us the Markovnikov product, only in ether form. So to summarize, ethers can be synthesized using a Williamson ether synthesis, which is an SN2 reaction, so you have to be aware of steric constraints. Ethers can also be synthesized using alkoxymercuration demercuration, affording the Markovnikov product.